Hello, binomial expansion time, um, which really means we're going to talk a lot about Pascal's triangle. And so, in order to do that, I figured we'd talk about the man Pascal. He's a French mathematician, amongst other things, living in the 1600s. Um, did a lot of really, really interesting stuff that I didn't actually know about. He's actually considered one of the more influential and great French writers during the classical period there. Did a lot of stuff with science and eventually um, quit all the math and the science stuff and just became a complete religious scholar at the end of his life after was in a buggy accident and had an epiphany. Um, he started the whole idea of probability theory. Supposedly, some friends of his wrote him a paper or wrote him a letter and asked him to figure out if they ended their card game that they were playing, who was most likely going to win and how to split the money. And so he started getting into some probability theory that not as deep as what it is now, and you guys don't even know about, but he started doing a lot of that. He built the first or the only mechanical calculator of the time when he was 17 because he saw his dad doing too much work to add and subtract things at his job and thought, I can make that better. I'll show you that in a second. He also invented the syringe, did a lot of stuff with pressure and liquids. And so a syringe, which is, like when you go and take blood or you get a shot, he basically invented that whole system there um, that we still use today. So he's a pretty crazy dude, did a lot of things. This is one of his first mechanical calculators. Basically, you can count these up. There's 10 of them. So, best as I can tell, is you would go and dial in these things to match up what numbers you were going to do, and your answers would start spitting out here. So you just kind of spin this box around with these different numbers and add stuff up and subtract it. And there's a bunch of gears and things going on inside there that he had to mechanically work out. It was pretty amazing at the time. He only ended up making about 40 of them total. This one they've got in a museum somewhere in Europe. He did so much stuff. The standard metric unit for pressure is actually named the Pascal after him, as you can see there and right there. This one's in kilopascals. We in America tend to use the PSI, pounds per square inch, but the rest of the world uses newtons per meter square, which is named after our boy Pascal. He's got his own law in physics that has to do with pressures with liquids. I don't really know what is going on here with this chart, but the triangle there is talking about the change in pressure and how that relates to all these other different factors. He's also very famous for what was called Pascal's wager. As I said before, he ended up quitting all the science and the math stuff to become a religious scholar. And so he was always deeply into religion. He was linked to kind of a weird offshoot of Catholicism at one time. So he kind of took a pragmatist approach and decided, either there is God or there isn't. Nobody's going to prove either way. So what he did is he kind of went through a rationale to prove that whether God exists or not, you have a whole lot more to gain by believing in him and being right that way than maybe if God doesn't exist, then what do you gain? You don't really gain anything. Everybody's in the same place, right? So he kind of put together a whole thing on that, and it became known as Pascal's wager. Kind of angered both the atheists and those that were deeply religious kind of equally. So he's pretty famous for that. His triangle, though, which is what we're going to use, goes back all the way to the 2nd century, supposedly to some people in India. People in China were using it, depending on where you are in the world. I don't know why that just happened there. It's known by different things. I'm not going to begin to try and say that, but he was a Persian guy living in what is now Iran, and had come up with his own version of it. This is what it looked like in China for this guy. And even this dude in Italy came up with it and used it for some things. All of these people and different cultures all around the world were all using it well before Pascal. But we know it as his because he wrote a book titled whatever that says. It's French, but it looks like traits of the arithmetic triangle. This is actually what it looks like in his book, that and what we're going to use. So most of the Western world in America and most of Europe calls it by his name because he did go ahead and use it a whole lot more. So what it is, it goes down to infinity as far as you want it to go. Um, this one's row 0, so row 1 technically is right here, and row 2 and on down. And what it is any two numbers next to each other add up to make the one below it. So here, like 15 and 20 add up to make the 35, and the pattern goes down that way. So here's a little animation for you to take a look at. I don't know how smooth that's going to come out on the video, but each two numbers that are connected next to each other add up to make the one below. And it's ridiculous all the different places that this thing comes up. And what we're going to do is we're going to use it for combinations, or here. So yeah, this is what you're going to get. It's a whole lot easier to use than what we're talking about here, but this is just different formulations for talking about choosing things. So let's say this one here, C, 3 and 2. We're going to have 3 things and we are going to choose 2 of them. How many different combinations can we have out of that situation? So it's kind of like you got, I don't know, 3 different colors of shirts and you get to buy 2. What different combinations do you have? It just so happens that that's going to match up exactly with the spot on the triangle that these things are all fitting into here. Alright, and what we're going to do today is we're going to use it for the binomial theorem to expand this on out. Yeah, basically it's going to take, like x plus 4, and if we pick a random pattern that's bigger than squared, like let's say the 3rd power, 4th power, 5th power, what's going to happen is our triangle, these numbers here, are going to help us out and keep us from having to do box method 5, 6, 7 times in a row. Alright, this is how. Alright, so we got a power of 4. If we go back and look at our triangle, we're going to look at this row, 1, 4, 6, 4, 1. What that does is that gives us our coefficients for our different powers. This is going to be a whole lot easier than it looks right now. You take 4, because that's our power, and we go on down. 4, 3, 2, 1, 0. So right here, we're just going down in power. For our front guy here, x, which is the front guy here. Now for our 3, we're going to start at the bottom and work our way up in powers. So 4, 3, 2, 1, 0 going upwards. What that does is it just kind of does all our powers for us. Then we multiply by our front numbers here, and we're going to be able to get it out without having to do x plus 3 times x plus 3 times x plus 3 times x plus 3 and work all that out by box method. So here we're going to get 1 x to the 4, 3 to the 0 is just going to be 1, so it's just x to the 4. 3 to the 1 is 3, times 4 is going to make 12 x cubed. Here we're going to get 3 squared is 9 times 6, and that's going to make 54 with an x squared. Here 3 cubed is, what, 9, 20, oh goodness. Let's see, 20, 27, 27, 27. 3 cubed is 27, we got to multiply that by 4 then and get 108. So this is going to be a 108x. And then lastly 3 to the 4th power, which is 81, and x to the 0 is just going to be 1. So these become all of our things. So x plus 3 to the 4th power is going to be x to the 4 plus 12x cubed, and so forth. And what this does is it saves us from having to do box method, not just that many times, but then we have even more, and then even more, like so. Nobody wants to do that much multiplying, so our triangle thing's going to help. So here, we're looking at a 3rd power, so we've got 1, 3, 3, 1, because that's the 3rd row of our triangle. We're going to put my 2x in here for all of these, and my y in here for all of these. My powers are going to go down on the x side, so 3, 2, 1, and 0, and then up on the right side, 3, 2, 1, and 0. And now it's just a matter of multiplying things out. Here we got to worry about That's going to go away. 2 cubed is 2 times 2 times 2 makes 8x. Here we're going to have 2 squared is 4 times 3 makes 12xy. Here we just need to multiply these two, so that makes 6x y squared. And then lastly, there's no numbers really multiplying here. We just that goes away to 1, so it's just y cubed. So you end up with 8x plus 12x. Oh, that was x squared right there. My fault. X squared y plus 6xy squared plus y cubed. Alright. So, I'm going to fill in all of our stuff like this. X's and my minus 2y. We're going to make sure we take that with us. Now our powers are going to drop from 3, 2, 1, and 0, and then up 3, 2, 1, and 0. Then we're going to deal with all of our powers. This one's going to cancel to a 1. This one will cancel to a 1. And there we go. Making sure we take note that this guy is going to multiply this to make my negative 6 here. Negative 2 squared is going to become positive 4 times the 3 makes that 12. But here, negative 2 cubed is negative 2, negative 2, negative 2. And that's why it comes out to be a negative 8. So we write it all out. And there we go. So doing it on our own, we've got another one that is cubed. So I'm going to write out the third line, which is our 1, 3, 3, 1. Now, we put our 2 in here because that's our first term, our minus 3x. Now the 2 is going to be starting out with 3, 2, 1, and 0. This one's going to go opposite and start at the bottom. 0, 3. That was horrible. 2, 1, and 0. Sorry about that. Alright. So again, the ones with the 0 powers are going to cancel out. 2 cubed is going to give me, what, 8. This one, I got 2 squared is 4 times 3 times negative 3 is going to make 12 minus 36x then. Here I got a 3 times a 2 times a negative 3 makes, let's see here. Negative 3 squared is 9, 18, I guess that's going to be positive 54 with my x squared. And then 3 cubed is going to be negative 27 x cubed. With our final answer written out like so. Alright, what is our third term? This one's getting specific, so we're going to write out our sixth version of the triangle. Now when we write that out, we're looking for the third term, so that's going to be right here. So that's the only one I'm worrying about. Powers are going to go 6, 5, so 4 is the power I'm worrying about here. And on down. Down here we're going to go 6, 5, 4, 3, that'll be a power of 2. So we'll put in my x and my 2y. So we're going to have 2 squared is 4 times 15 will make 60. And then x to the 4, y squared. Alright, I think with that we're going to have to go to a part 2 there for the last few examples. So go ahead and hit part 2.